This is the next as a explaining. This is the next point from the architecture, that is the execution unit. BIU and EU, there are the two parts in a architecture. In the last lecture we studied the BIU. Next is the execution unit. This execution unit is responsible, EU is responsible to perform the execution of instruction that is fetched by BIU, that is fetched by BIU, that is a bus interface unit. That EU contains the control circuitry to perform the various internal operation, and there are the in that execution unit consists of ALU, that is the ALU arithmetic logic unit, ALU. Next is a general purpose registers, that general purpose register, pointer register, index register, operand register, flag register, and segment register. These are all in the in a execution unit. That is a execution unit. That execution unit is responsible to perform the execution of instruction that is fetched by bus interface unit. And in this execution unit consists of 8 general purpose register, 2 16-bit pointer register, 2 16-bit pointer register SP and BP, and 2 index register. That 2 index register are the SI and DI, and operands and flag register, This EU consists of, execution unit consists of. First is the arithmetic logic unit, that is a ALU. This ALU is also called as a 16-bit processor. This is ALU is called as ALU is the of a 16-bit, so it is called as processor is a 16-bit microprocessor. So processor is a 16-bit processor, means that ALU is responsible to perform the all arithmetic and logical operation like addition, subtraction, multiplication, division, etc. for the 16-bit data. So ALU is a 16-bit, so processor is a 16-bit. Next is a register organization. That is in this register organization, that is a separately one in a register organization. This is the one part. In the ones separately one question is asked, that register organization. This is the register organization. In that EIU, this is the one part, register organization. One separately question is asked, explain the register organization of 8086. In this register organization, there is a general purpose register. 8086 having 8 general purpose register, that is AH, AL, BH, BL, CH, CL, DH, DL. These are 8-bit. When they both are combined, AH and AL, there is a one AX register, that is a accumulator register. This is a 16-bit. When BH and BL, BH is 8-bit, BL is a 8-bit. BH and BL combined, that we referred as a register as a BX. CH and CL are 8-bit. When they are combined, that is referred as a register as a counter register as a CX. That CX register is a 16-bit. That is a 16-bit. CH is 8, CL is 8. So CX register from CH and CL we referred as a counter register as a 16-bit register. And when DH and DL, DH is a 8-bit, DL is a 8-bit register. When they are referred as a DX register, that DX register as a data register, that register is a 16-bit register. And AL and AH register, AH is a 8-bit, AL is a 8-bit. That AH and AL referred as a AX register, that is the accumulator register, that register is a 16-bit register. That AX register is a 16-bit accumulator register. At the lower of 8-bit of AX is designed by AL register, and upper 8-bit are designed by AH register. And AL and AH we combine, we get the 16-bit register as an accumulator register as a 16-bit register. This register is more important, general purpose register having the multiple operation. In this accumulator register we store the data or result. Next register is a BX register. This BX register is for memory related instruction register. BX is used to store the 16-bit effective address of the corresponding memory location. 16-bit effective address of the memory location. For that purpose, that BX register is used. That register is a 16-bit. Next is a counter register, CX. This counter register is used for the string instruction, and that microprocessor use the CX register as a 16-bit counter. Similarly, this counter is used for the rotate and shift instruction. In the next chapter we study the that instructions. That is counter. For that this instruction is used as a counter register. Next is a data segment register. That is a data register. When we use that instruction for in and out instruction, there is the address is stored. That is the address, port address, that input and output port address is stored, and that address is stored in a DX register. That address is stored in a DX register. If the result of multiplication is during the input and output instruction, in and out instruction, that register port address is stored in a 16-bit register during the IO instruction. Next is a pointer register. This pointer register, that is a pointer register is SP and BP. That other words, that instructions SP and BP are the stack pointer and base pointer, which is called as a pointer register. These registers are used during the stack memory related operations. Stack related means SS memory. In that stack related memory, these registers are used to hold the 16-bit offset of the within the particular segment register. Offset of that particular segment. That particular segment means which stack segment. In that stack segment, there is a SP and BP register is used. Next is the index register, SI and DI. That 8086 has a two index register, that is a source index and destination index. Source as a SI, destination index as a DI. This is a particular use for the string instructions, string manipulation, and SI is generally stored the offset of source data in a data segment, in a string of the data segment, and DI is used to store the offset of destination in a data. Then what is the address? Offset means that the processor having 20-bit starting address, physical address of the memory segment, that is called as a base address, which is always present in a segment register, and the address is associated within any instruction or data, that is called as a effective address or offset. That for every memory having 20-bit starting address, but for the address that associated with any instruction or data type, that is called as a 16-bit effective address or displacement. That offset value is stored in a offset of source data and offset of destination data, that is stored in a SI and DI. Next is a segment register. Segment registers are code segment. This is used for the store the 16-bit data base of the code memory segment. Data segment is stored the data of the result of the program. Next is the extra segment, is used for the additionally storing the data and result. Stack segment is used to store the stack data. Next is that is operands. This is a explanation of total as a register organization separately asked from the EU, and one question is asked, what is the EU and what are the blocks in a EU, what is the function of EU, and operands in that, this is the register organization, and in a that architecture there is a operands. That operands, this is the explanation of total register organization, and there is another block ALU explain this total general purpose register, pointer register, index register is a register organization. Separately one question is asked, explain the register organization of 8086. Next is the operands from EU. This is a 8086 microprocessor, has a 16-bit temporary register as an operand register. This register is used only by microprocessor. This is a temporary register and used by microprocessor. Next is a flag register. This register is also 16-bit register. This is a 16-bit register. That flag is a flip-flop. The flag is a flip-flop which indicates some condition, which is produced by execution of instruction or controls certain operation of the EU, and that flag register is a 16-bit, and that flag register consists of status flag and control flags. This flag is a flip-flop. That flag is a flip-flop which indicates some condition that is produced by execution of an instruction or controls certain operation of the EU, and that flag register is a 16-bit flag register. One separately question asked on this point, that draw the flag register structure of 8086 and describe the operation of each flag. And that flag register are two flags, namely status flag and control flag. This is the one separately question asked, register organization from EU, and another one question is asked, that is this is a flag register format. That flag register is a 16-bit. So D0 to D15, this is a 16-bit. And in this there are the control flags and status flag. Status flags are carry flag, parity flag, auxiliary flag, zero flag, sign flag, overflow flag. And control flags are direction flag, interrupt flag, trap flag. These are the control. One question is asked, which are the status flag and which are the control flag, and another one question is draw the flag register format of 8086 and describe the operation of each flag. That is a carry flag. That carry flag is for the D0 bit. When the microprocessor performs the addition and subtraction of the two 8-bit number, carry generated or borrow generated, that is required after the addition and subtraction, that is directly copy into that carry generated when perform the processor addition subtraction operation. That carry or borrow generated, that directly copy into that carry flag. Next is a parity flag on D2 bit. X don't mark, that is not used, that bits are not used, so that is a cross. Next flag is for D2 bit, that is a parity flag. This flag is used to indicate the parity of the result. If the result is an even number, if result that operation is processor is perform the addition, subtraction, multiplication, operation, division, if that result is a even number, then parity is a even parity. And if result is a odd number, then that parity is a odd parity. Then PF is 0 for the odd parity and PF is 1 for the even parity. When PF is 1, even parity generated. When PF is 0, odd parity generated. Next is the auxiliary carry flag. When the processor is perform the addition subtraction of the two 8-bit numbers, then carry and borrow is generated. And carry and borrow is generated after the D3 bit, that is a D0 to D7 are bits, that 8-bit numbers. We add the two numbers from D0 to D7 bit, but from the D3 bit to D4 bit there is a one carry generated. From the D3 to D4 bit there is a carry generated. Then auxiliary carry flag is directly copy that flag in a auxiliary carry flag. That is from D3 to DT. We add the two numbers from D0 to D7. There two numbers we add, and from D3 to D4 bit there is a carry generated. Then auxiliary carry is generated. That carry flag directly copy into the carry flag. Zero flag. This if we perform the operation addition, subtraction, multiplication, division. If result is complete zero, all the bits of result are 0, then ZF is 1. All the result that is a 0, then ZF flag is 1. If the result obtained is non-zero, then ZF flag is 0. Status of that flag, indicates some condition that produced by execution of execution of instruction or control certain operation of EU, that is known as a flag register. That condition indicating that every flag. Sign flag. This sign flag is used for the sign number. This sign flag is used for the sign number. If result is obtained negative, then result is obtained is negative, then sign flag is 1. Sign flag is 1. If the result is obtained positive, then sign flag is 0. Next flag is trap flag. This trap flag is if the trap flag is set, the processor enters into single step mode operation, and in other words, that is a trap interrupt is generated after the execution of instruction, means the processor executes the current instruction and control is transferred to the trap interrupt service routine. Trap interrupt service routine, that is the trap flag. That is the trap flag. Next is the interrupt flag. Interrupt IF flag. This is an interrupt enable or disable flag. If this flag is set, then 8086 INTR of 8086 is enabled. If this flag is reset, then interrupt is disabled. Interrupt is disabled. Means in a processor, if interrupt is generated, then from that pin, that interrupt is that flag is set or reset. If this flag is set, then interrupt is enabled. Means interrupt is generated. If interrupt, that is if IF flag is 0, if disable or IF is 0 or reset, then interrupt is disabled. Interrupt is not generated in processor. That is the indicated by that interrupt flag. Next is a direction flag. This flag is used to direction flag is this used to instruction related to, that is used to string manipulation instruction, and this flag is set for the string bytes, that is access from higher memory address to lower memory address, and memory addresses, and memory, that is when it is reset, that is string bytes are accessed from, when this flag is reset, then memory is accessed from lower memory addresses to higher address memory. When it is reset, that string byte is accessed from lower memory addresses, and direction flag is set by executing the STD instruction, and that is reset by the CLD instruction. CLD instruction. This is used for the string manipulation instruction. When this is set, this is access from higher memory to lower memory, and when it is reset, this is access from lower memory to higher memory address. That flag is a direction flag. Overflow flag. Overflow OF flag. If result is obtained limit beyond the limit, that processor is a 16-bit, but beyond the limit means that answer is if 32-bit, 64-bit, beyond the limit, then the result is said to be overflow. That result is said to be overflow because this processor is 16-bit. Beyond the limit, that answer is obtained, that is 32-bit or 64-bit, then overflow flag is generated. If the result is said to be overflow, then overflow flag is 1. Then overflow flag is 1. If the result is obtained within the limit 8-bit or 16-bit, then OF is a 0. OF is a 0. This is the flag register in the EU. In the EU consists of ALU, general purpose register, that general purpose register, pointer register, index register, operand register, flag register, and segment register. And separately one question is asked, explain from EU, explain the register organization. That register organization accumulate that table, and separately one question is asked, explain the flag register of 8086 from that EU. This is a complete your architecture, that architecture divided or block diagram of 8086 divided into two part. CPU is divided into two part, functional part, that BIU and EU. BIU and EU, and this is the total block diagram of 8086 consists of BIU and EU. Next lecture we study the physical address generation and memory segmentation.